So we have just seen that how heapify work. Now we are going to see that using heapify how we are going to form a heap out of the random sequence of a number. So this is a random sequence of number. If we store it in an array, we'll have a complete binary tree based data structure like this. Now we have to see that where the condition of max heap holds or does not hold. Now there might be two approaches. One is that we are doing it top down and bottom, or another is bottom up. So we'll look into these two approaches, which one is best for us. So if I go top to down to check the condition of max heap holds or does not hold, so first I'll check for 16. It will be compared with 4 and 10, so the condition holds true. Now we'll move down. Now I'll check with 4, 1 and 7. Now according to heapify, there will be a swapping between 4 and 7. So 7 will come here and 4 will come here. Now 4 will be compared with 2. No swapping is required. Fine. Now 10 is compared with 9 and 6. No swapping is required. Now coming to the next level, 1 is compared with 8 and 3. Again the swapping is required. So now 8 is swapped with 1. No further swapping is required. Now 3, no swapping is required. For 2, no swapping is required. If I move top to down, I have done the swappings wherever the condition was not holding. But just check whether it is a max heap. No, it is not. The condition over here for a max heap doesn't hold. 7 is less than 8. Ideally, 8 should have been at this place and 7 should have been at this place. So what we were doing, we were swapping and we were looking at the descendants whether they are holding the max heap property or not. So we were going down while we were swapping. So what happened, while we were swapping, there was a problem at the upper level. So we cannot go in both direction, that we have to check downwards also, descendants also and ascendants also. So we cannot do this. So the top down approach fails here. What we have to do next, we have to see the impact of our bottom up approach. So just I am moving back to my initial tree, which was 4, 1, 7 and 8. Now if I move bottom to up, what will happen? I have to follow the reverse direction. So first element is 2. This is a leaf node, so no property checking is required. For again 3 is a leaf node, so there are no descendants, so I need not to check. Again 8, I don't need to check. For 6, there is no required to check. 9, we don't require to check. So if you see, for leaf node, we don't even require to check that whether they hold the property or not. Okay. Now for 7 and 2, it holds the property. Now next 1 is compared with 8 and 3, so there will be a swap between 8 and 1. So 1 will come here, 8 will go here. Fine. Now we'll move to 10. 10 is checked with 9 and 6, the property holds. Next comes 4 is checked with 8 and 7. Again a swapping is there between 8 and 4. Now we'll check 4 with 1 and 3. So again the property holds, doesn't propagate further. Now we'll check it at the root level. 16 is checked with 8 and 10. So now you can see this is a max heap. So we have two important points here. The first point is we have used bottom up approach. And the next point is there was condition checking was not required for leaf nodes. So for leaf nodes, I need not to check my heap property. So now we will look into the algorithm of building a heap. We just named this algorithm as build max heap for the obvious reason, and we have passed the parameter array A, which will contain the random sequence of numbers that serve the purpose of data nodes as well. Now what we have to do, we have to calculate the index of last non-terminal node, because we are starting to call heapify algorithm in a bottom-up approach from the last non-terminal node up to the root node. So we have a direct formula to calculate the index of last non-terminal node, which is if we have total number of nodes is n, then the last non-terminal node will be n by 2, then floor function applied on it. So this algorithm is quite simple. So first of all, we're going to store the length of array A as the heap size. Then we have to make a loop from the index of the last non-terminal up till the root node, which is obviously at index 1. Next we have to do is I have to call max heapify for every I, for every non-terminal node in a reverse order. I am calling the max heapify algorithm. So coming to the complexity of this algorithm, the for loop line will be executed n by 2 times, and then the complexity of heapify is O log n. So a total complexity of build max heap will become O n log n. However, this complexity is not asymptotically tied. So we will further calculate the complexity and we will see that this complexity comes out to be O n. So now we will see that how the complexity of build max heaps comes out to be O n. So this is a complete binary tree. Now you see that if I'm going to call the heapify algorithm, first of all I'm not going to call it for my leaf nodes because they are already heapified, they don't have any descendants, so there is no need to compare this leaf nodes with some other nodes, so they are already heapified. At next level, so that up one level up at these green nodes you can see, we will call the heapify algorithm. So now whenever we are calling the heapify algorithm, the comparison will be made among the nodes of this subtree. So while calling heapify for this node, I don't have to go for this node. I need not to make a comparison with this node. I just need to make a comparison among the nodes which reside descendant to this node only. So similarly, when I'm talking about this node, the subtree formed by this node as a root, only the nodes of that subtree will come into the scenario of comparisons. Similar, when I go up, the complete tree will come into the scenario. But when we build the heapify algorithm, we said that the complexity is O of log n, considering that we will travel either the left side of the tree or the right side of the tree, and then we will go keep on just traveling the nodes corresponding to the maximum depth. So that's how we calculated the complexity O log n for heapify algorithm. But here the calculations differ because every time we are calling heapify, the height of the tree is changing. So for this, the height of the tree is 3. For this, the height of the tree is 2. For this, the height of the tree is 1. And for leaf nodes, the height of the tree is 0. So how this will impact? So now we'll count the number of nodes at each level first. So here you can see we have 8 nodes. At next level we have 4 nodes, at next level we have 2 nodes, and at root level we have only 1 node. So for this we have a formula using which we can easily calculate the number of nodes at each level given a tree. So if we have n nodes in the complete tree, then the nodes at a particular levels will be n divided by 2 raised to the power h plus 1 and then ceiling function applied on it. So now calculating the height. So for the root node, if I consider this node, the height formed by the tree with root at this node will be 3. If I consider the level next, then if I treat this node as the root node, the height of the subtree formed will be h is equal to 2. Similarly, at next level, the height of the subtree formed will be h equal to 1. And at last, for the leaf nodes, the height will be equal to 0. Now we will put this height into this formula and the total number of nodes, that is n, into this formula, and we'll verify that whether it is working or not. So the total number of nodes in this particular tree is 15. Now let's check. For the first level, this will be 15 divided by 2 raised to the power 3 plus 1, and then ceiling function. This comes out to be 2 raised to the power 4, that is 16. So 15 divided by 16 ceiling function. This comes out to be, of course, 1. So as I can see that there is only one root node present at this level. Now coming to the next level, the calculation will be 15 divided by 2 raised to the power 2 plus 1. This comes out to be 15 divided by 8 and then ceiling function. So simply the answer will be 2. So as you can see, here are only 2 nodes. For h is equal to 1, the value comes out to be 2 raised to the power 1 plus 1 ceiling function, then 15 divided by 4 ceiling function. This comes out to be 4. So as you can see, we have 4 nodes. Next, for the leaf level, we have 15 divided by 2 raised to the power 0 plus 1, then ceiling function. So this comes out to be 15 divided by 2 ceiling function, and that is equal to 8. So you can see that we have 8 nodes. Now why we have calculated these number of nodes at each level? What was the purpose? So let's move ahead. As you can see that I am going to call heapify. Every time we are going to call heapify equivalent to the number of nodes at that particular level. Say for leaf level, we have these 8 nodes. So if we had to call the heapify, we are going to call it for this node individually, then this node, then this node, and then this node, and so on. Similarly, for this level, if I am going to call heapify, I am going to call it for this subtree first, then this subtree, then this subtree, and then this subtree. So I am going to call heapify equivalent to the number of nodes at that particular level. So for level at root, I am going to call heapify only one time. At level 2, I am going to call it for 2 times. At this level, I am going to call it 4 times, and at this level, I am going to call it 8 times. Now at next step, I have to see that what will be the complexity of my heapify algorithm corresponding to each level. So as you can see that if I call heapify for my leaf levels, there is no need. I'm not going to call it for my leaf because my leaf are already heapified. So at height equal to 0, I need not to call heapify algorithm because my leaves node are already heapified. Coming to the next upper level, for this I have this subtree, and similarly for this I have this subtree, and so on. So in this, if I call heapify algorithm, either I'll exchange with this node or this node. So this is the maximum possibility that either I'm going to make an exchange here or I'm going to make an exchange here. So I'm going to call heapify just for the one time. Coming to the next level, that is this level. If I'm going to call heapify for this node, so either I'm going to make a first exchange with this node or with this node. Now whatsoever I'm exchanging, the next possible exchange will be at the next level. So there are maximum 2 heapify possible if I'm going to this level. Similarly, if I go to root level, the maximum number of exchange or the maximum number of times I'm calling heapify will be 1 for this level, then another for this level, and third time for this level. So as you know that for this level I have called heapify for a maximum of 3 times. So I'm considering this as the worst case. So I'm not going to call heapify for more than 3 times. For this level I'm going to call heapify for 2 times. For this level I'm going to call heapify only for 1 time, and for this level I'm not going to call my heapify. So this is 0. I can simply say that this was my height as I predicted here. So if I generalize this into a formula, this comes out to be that number of nodes was n divided by 2 raised to the power h plus 1 ceiling function applied on it. Then the heapify function is called for a maximum of 3 times, 2 times, 1 times or 0 times, that is order of its height. So order of its height times this particular algorithm we are going to call. Now this is a generalized formula. As you can see that n is fixed for this complete tree. However, the height will vary. Every time the height is going to vary. So height will vary from 0 to log 2n. So what we have to do, we have to make a summation where h will vary from 0 to log to the base 2n, and then our formula, which is n divided by 2 raised to the power h plus 1, then order of h. Now we're going to see that how we're going to solve this expression and calculate our complex. So this was our equation which we have to solve. Now as you see that my h is varying from 0 to log 2n. Now within this I am expanding this expression, so I am writing it as 2 into 2 raised to the power h, and I am writing OH as a constant multiplied by h. Now I have to see that what terms are varying with h. So with h only this term 2 raised to the power h is varying and this h is varying. N is constant, 2 is constant and c is also a constant. So I can take out this from the summation. So this will be n multiplied by c divided by 2. Now within the summation, which is from h equal to 0 to log 2n, I have h divided by 2 raised to the power h only. So this is my new equation now. Now if I extend my limit up to infinity, what will happen? So if I'm extending this h equal to 0 to infinity, first of all this equal to sign will change to less than equal to, because whatsoever is there, if log 2n, I'm making it, I'm extending. So whatsoever value will be evaluated here, this value will obviously will be less than when I'm calculating this up till infinity. So h divided by 2 raised to the power h. Now what was the purpose of extending my limit? The purpose was to simplify my equation, because this term now will become a harmonic progression expression which is equivalent to 2. So I can simply place the value 2 at this position. So this comes out to be n into c divided by 2 multiplied by 2. Now I can cancel this 2 with this 2 and the overall equation will become n multiplied by c. That this means c is a constant, so the overall complexity will be order of n. Why O? Because I have taken here an upper bound. So an order of n will be the total complexity of a build bags heap algorithm. So once we are done with the heap, we come to our main motive, and that was heap sort. Now we have to sort our elements. So as you can see, this is a max heap and my array at this particular position is like this. Now I have to sort the elements. So I know if this is a max heap, where I will find the largest element. So the largest element will for sure exist at root. Fine. So this would have been the last element of my series. So what should I do? So first of all, I will exchange my last element with my root node. So 2 will come here and 16 will go here. So similarly, the position will be shifted in this case in array. So 2 will come here, 16 will go here. Now if I consider that this is going to be the array where I am going to sort my elements, so I can see that my last position is now sorted. I have my largest element at the last position right now. I'm not talking about the rest of array, but my only last position at this particular moment is sorted. What I will do, I'll consider that my heap is now not of 10 elements. The size is reduced by 1 element. After I have shifted my largest element at this place, my heap size will from this to this only. Now how this whole procedure is going to work? So 16 is not here. Now again my heap property is not holding at this moment. So what I have to do? I have to call heapify again. So let's see how heapify works. Heapify will compare 2, 8 and 10. So the swapping will be between 2, 8 and 10. So these two elements are now swapped. Now again 2 is compared with 9 and 6. So there will be a swapping between 2 and 9. Correspondingly in array 2. Now this will be my max heap. So now my work is complete. What was my task? I have taken my root node, I have taken my last element, I have swapped the 2 elements. So at last position I have my largest element. I have considered that this element is now no more a part of heap. So my heap is reduced to this size. Now what I have done, I have again called my heapify algorithm to convert my all the tree in the heap, the max heap. Okay, now let's move ahead for the next element. Now I see that my root element is 10. Of course it is my max heap, so my root element should be the largest element. So what I'll do, I'll swap my last element with my root element. So this will be swapped here. Now again I'll consider that my heap size is reduced by 1 and this 10 is no more a part of heap. Now you can see that my largest and my second largest elements are there in place in the sorted list. 10 is no more a part of this heap now. Now again I have to call the heapify algorithm and I have to do the shiftings. So 3 is compared with 8 and 9. What will be done? Obviously 9 will go up and 3 will come down. Correspondingly there will be adjustments in the array 2. Now 3 is compared with 2 and 6. So 6 will come up and 3 will go down. Fine. Now again this is the max heap. We'll start the procedure again. Now 9 is the largest element. 9 will be swapped with 1. And this will be 9. Now my largest element, my second largest element and my third largest element are in place, and I will consider that my heap size is again reduced by 1. Again heapify is called 1, 8 and 6. So there will be a swap between 1 and 8. Again heapify is called, there will be a swap between 1 and 7. Now this is a max heap. Let's move ahead. Now 8 is the largest element, it's on the root. Now we'll swap it with the last element, which is 3. So we'll swap 8 and 3. So my last 4 elements are in place, they are sorted and they are in place. So I'll remove this from here. I'll again call the heapify algorithm. So there will be a swapping between 3 and 7. Again there will be a swapping between 3 and 4. So at last we will have 7, 4 and 3 here. Again repeat the procedure. Now 7 is swapped with 2. Now these 4 elements are in place, 5 elements are in place. We'll remove this from here. Now again the swapping. So the swapping will be between 2 and 6. This is a max heap again. Now we'll again move 6 and we will switch it with 1. So 1 will be at root and 6 will be at. Now my last 6 elements are in place. Again, so 1 is swapped with 4. Again 1 is swapped with, so 6, this 6 was no more a part, so 1 is swapped with 3. Now we will swap 4 with 1. Sorry, I have not placed this. So we have not made the adjustment last time. So now this will be swapped here. 1 will come here, 4 will come here. Now again 4 is in the correct place. So 4 will be removed from this heap. Now 1 will be swapped with 3. Now you know that this is a max heap. What I have to do next, I have to swap 3 with 2, and then this 3 is deleted. Again this is in place. Now I am left with only 2 elements. So I know at root I have the highest element. So 1 is swapped with 2. And I am having 2 at the place, so no more heapify calling is required. So when I left with 1 element, I know it is sorted in itself because it need not to be compared with any other node. So if I call heapify again here, it will be a waste of resource. So what we do, we call heapify from last element up to the second element only, as the 1 element remaining will automatically be in place. So this root node will be automatically in place, and you can see that we have the sorted list now. So now we will look into the heap sort algorithm. We simply name this algorithm as heap sort, and we passed a parameter array A that contains the random sequence of number which needs to be sorted. Now, at first step, we'll simply build a max heap out of this array A using build max heap algorithm we just studied. Now, once the heap is built, we have to run a loop in a reverse direction from the last element that is being calculated using length of A up till the second element. We are not going to perform the procedure for the element remaining at index 1 because a single element remaining is sorted itself. Now, we will just exchange the root element with the element pointed by the index I. Doing so, we are just placing the last element at the root position and the root element at the last position. So now the root element was the highest one in the max heap, which is now placed at the last position. That is the correct position in a sorted array. Once we have done this exchange, we have to reduce the size of heap by 1. So now we are excluding the element sorted from our heap. Now finally, we know that the heap property is not satisfied at the root position because we have just made an exchange at the root position. So what we have to do? We have to call max heapify for the index 1. Doing this for the elements up till 2, we will sort each element one by one and we're going to place it at the correct position in the array. And for the last element, as I said before also, we're not going to call this algorithm, we're not going to do all this code because the last element is sorted itself. Now looking into the complexity of this algorithm, the build max heap algorithm will run in the time complexity of O(n). Then the loop will run for n minus 1 times. Now within this loop, we are calling these two statements which will take a constant time, and further the max heapify will run in the complexity of order log n. Now just having a calculation for the complete algorithm, T of n will be equal to On, that is this build max heap complexity, plus the heapify algorithm is called for n minus 1 times, so n minus 1 into O of log n. Now computing further, we'll find out that this comes out to be On log n. So in this video, we covered the basics of heap. We have seen that how heap is built, what is a heapify algorithm, how we are going to build a max heap, what is heap sort, and what are the complexity for these algorithms. So if for any queries or any doubts, you can just write an email to me and I'll revert back to you.